Hello, I'm an old guy and I do maths. Now, what we're looking at today is the graph of y equals tan of x and its asymptotes. So there are a few things to cover here. First of all, what is an asymptote? Well, you'll notice that on this scale that I've drawn here, this I suppose part of a Cartesian plane, I've got some dotted lines that pass through pi on 2, 90 degrees, and 3 pi on 2, 270 degrees. Now, these are how we illustrate asymptotes on a graph, and an asymptote is a value that a function or a graph approaches but never touches. Now, those of you familiar with tangents will know that if you ask your calculator to find the tangent of 90 degrees, it will do the following. Syntax error or domain error or something like that. And that is because the tangent of 90 degrees is undefined. The tangent of 270 degrees is also undefined, and I'll just illustrate that for you. Tan 270, we're going to get the same result. There we are. Now, so these are values on the graph that a tangent approaches but never touches. Now, a tangent graph looks like this. And this is between 0 and 2 pi, 360 degrees. So just let me do the artwork here. It passes through pi, 180 degrees, and again it approaches this asymptote from the other side but does not touch. And our final part of this, to take it to 2 pi, looks like that. Now, as you can see, this is a very different looking graph to a sine or a cosine graph, and it behaves differently. The period of this, which is the distance that it takes to go through a full cycle, is 1 pi. It is, for instance, from here to here. 3 pi on 2 minus pi on 2 equals 2 pi on 2, which equals pi. The period is, for a standard tangent graph, is pi. It's this distance here, 180 degrees, which is half that of a standard sine or cosine graph. Okay, now other features. Again, you will notice if you have a look at my work on sine or cosine graphs that their maximum and minimum values in their standard form, y equals sine x, y equals cos x, their range is from -1 to 1. That's not the case with tangents. So if we go looking for for instance, for the tangent, let's just pick a number, 85 degrees, you'll see that it's equal to 11 point something, so quite a bit bigger than 1. And as we approach 90 degrees, but we don't get to it because the tangent has no value, it's undefined at 90 degrees, but at 89.999 degrees, it's a bigger number. It's a considerably bigger number. And as that approaches ever closer to 90 degrees, this number gets bigger. Hence, the range of this function, unless we somehow limit the domain, is between negative infinity and positive infinity. And that's very different to what we see with standard sine and cosine graphs. When we start playing around with the period, which is not something that we will look at here, but just a fair warning, these asymptotes move. They either pull apart or they come closer together. The other thing to note is that, again, if you've been dealing with sine or cosine graphs, it's possible to increase the amplitude of both a sine and a cosine graph. Now, it is also possible to put a number other than 1 in front of this function, and what that does is it either does something like this. It increases it increases the values of the tangent, so it pulls away from the x-axis, or if it's a number smaller than 1, it will come closer to the x-axis. But in either event, it will not touch this asymptote. So think back to when you were learning trig values. You would have seen that the tangent of 30, 60, 45 degrees, they were all defined and they had their values. But you would also have seen, if you were looking at a table of this, that the tangent of 90 degrees was undefined. And that brings us back to these asymptotes. Now, that's all I wanted to point out in this video. There'll be other videos where we look at the way in which this function can be altered to make the graph move and do various other things, including the movement of these asymptotes. Pretty much everything that you can do to other trig functions you can do to this. It just tends to manifest itself in a slightly different way. Anyway, that's a good place to stop. You've seen standard tangent graph. Hopefully you've understood how it's put together. You can see that I think there's one other thing that I could say. If we take the unit circle, you can see that tangents are positive between 0 and 90. There we are. They're negative between 90 and 180. And indeed, here we are, positive between 180 and 270. And negative again between 270 and 360. Okay, so that's probably the only other thing that I want to say. So thank you very much for watching. I hope that you found this useful, and I'll see you on the next video. Don't please forget to subscribe. See you later. Bye.